In part 2 of this guide, we are going to start off with soldering the ground and 5-volt wires to the power distribution board, and then we're going to solder them directly to the flight controller on the appropriate pads. It's important to note that here I have already pre-tinned all the pads on the power distribution board and pre-tinned the wire ends so that we can have easy solder flow on heat transfer during soldering. Here you can see that I'm actually applying heat to one side of the revolt while pushing the wire in through the other side of the revolt. This is because I use a high heat iron that allows me to quickly and easily flow the solder and push the wire through the flowed solder so that it has a good, solid, stable connection. I do this only on the ground and power pads for the revolt. I have went ahead and soldered all the other components of this build to the power distribution board, including the ESCs, the power wire, and the VTX. Now I'm going to solder the signal and ground pads from the ESCs directly to the flight controller. As you can see here, the red wire is a signal wire and is being soldered to motor 3 on the revolt, and the black wire is a ground wire being soldered to ground. I'm going to go ahead and do this for all 4 corners. As you may have noticed, the flight controller is actually upside down here in this build. This is because I like to mount my receivers and sometimes my VTXs on top of the flat surface of the revolt. Here I'm going to go ahead and solder the ground wire for my receiver to the ground wire, the 5-volt power wire to the VCC wire, and I have already bridged 5 volts. And I'm going to solder the signal wire to TX1 on the revolt. I have also already soldered the invert and TX1 pads, and the reason I'm soldering them to TX1 is because I'm going to show you how to set this up both on BB425 and on RF1. Now I just used some double-sided sticky tape to mount my receiver on top of the flat side of the revolt, so it's a good way to protect your gyro and your other things and having a good mounting surface that you can use. For this setup process, we're going to go ahead and set up BB425, and then we're going to go ahead and flash and upgrade to RF1 and then set up RF1. First, you need to go ahead and go to your Chrome apps and open the RaceFlight configurator. The latest should be 4.2.7. Now this is the Chrome configurator that is BB425 or beta build only. Next, you'll connect your flight controller, which shows up as COM port 15. Go ahead and connect. And then as you can see, you have several tabs that look like CleanFlight tabs because this was built off of CleanFlight. Now, if you're using a FreeSky receiver with inverted S-Bus protocol, you're going to need to flash a specific firmware file. You can get that file from raceflight.net/download, and it is the V2 inverted S-Bus BB425.bin file. So what you're going to want to do is you have 2 options. You can flash this flight controller in DFU mode, or you can flash it in RFBL mode. If you want to flash it in DFU mode, you can select the DFU mode button and it will put it in DFU mode. But you can also flash in RFBL just by going to the firmware flasher page, loading the local firmware, which is in this case, you're going to want to load Revolt BB425 Spectrum Telemetry Revolt V2 S-Bus. That is the file that you want to load. Now you're going to go ahead and press flash firmware. It will put your flight controller into RaceFlight bootloader mode, say preparing for awesomeness, and then you can press flash firmware one more time, and after a few seconds it will then begin to flash the flight controller. As you can see, the firmware has been flashed and it has already kicked out the flight controller from RFBL mode back to regular VCP mode to where you can connect again. So go ahead and connect your flight controller. For S-Bus, you're going to want to enable UART1 serial RX on the ports tab. This is because we soldered the S-Bus cable to TX1 on the Revolt V2. Save and review. Next, you can go to the Configuration tab, and you have your mixer standard stuff. You're going to select S-Bus, obviously, but you also have Spectrum and iBus and other serial protocols. You can select multi-shot or one-shot, and if you have multi-shot, you can also select your motor PWM rate to 32,000 and set your loop control all the way up to UH32. This is the Revolt only. If you do that, you're going to want to change your sensor configuration to gyro only, and you're going to also want to unselect black box. You can save and reboot. Next, you have your PID tuning tab, which has the standard PIDs that are able to be tuned, as well as your rates, expos, and acro plus, filter levels, gyro LPFs, and yaw determ LPFs. Next, you can go to your receiver tab, and you can change your channel map if you want to. I'm going to go ahead and turn my radio on to show you that it works. As you can see, you now see input on this receiver tab. You can go left or right on your yaw. All my channels are correct, as well as my auxiliary switches. You can press save if you made any changes, like setting your RC deadband or your yaw deadband. Next, you can go to your modes tab, and I always like to put ARM and schizo mode on the exact same switch. This was all that I ever used in the RaceFlight BBs, but they also have brain drain mode and pro smooth mode, which you can use. Simply save the tab, EEPROM shows saved, and you're good to go. Here you can calibrate your ESCs. Now, as you can see here, it shows 990. And so if you select this and move the slider, nothing happens. However, I'm going to go ahead and turn my radio off for this because this is important. The reason why this happens is because as you move through the pages, the hardware failsafe kicks in, and so that's why it shows 990 here. Simple fix to do this is to go back to a page you've already saved, save and reboot it. Then you'll go straight to the motors tab. And if you want to go ahead and calibrate your ESCs, now you can, because they all show 1000. So how to calibrate your ESCs is simple. You're going to select this after you've removed your propellers to enable motor control. You're going to move master throttle all the way to 2000. Then you'll plug in your battery and you'll hear the beep tones, the calibration tones. And then once those the first set of calibration tones is finished, you're going to move your master throttle all the way down to 0. You'll hear a second set of calibration tones and your calibration is complete. You also have the option to go to your ESC programming page. To flash your ESCs on the ESC programming page, simply press props off LAD, and then you can change your settings and your motor directions as well as flash them to the latest firmware that is contained within the GUI. You also have your LED page that you can set up. Check your sensors, download and erase your black box logs from Data Flash. You also have your CLI, which you can use for anything that you may need to if you want to do a dump or want to troubleshoot. Now we're going to go ahead and flash your Revolt to RF1. It's a very simple process to flash and set up. So first you need to go ahead and go to the RF1 beta link. You can find that on our Slack channel in RaceFlight 1. You'll go there and you'll download the client that you need, whether it be for Mac, Linux, or Windows. And then you'll also download the firmware. Once you have that, which in this case I have on my desktop, you're going to connect to your BB425 flight controller, and you're going to put the flight controller in DFU mode. If it doesn't immediately boot out, you can exit out of the app, reopen the app, and you'll see it is in DFU mode. Next, you go to firmware flasher, and you'll load firmware from a local file. Now, my folder is on the desktop, so I'm going to load Revolt 192, which is the .bin file for RF1. This is the latest beta file, so I'm going to load it and then flash it. As you can see, the Revolt has successfully flashed, and RaceFlight 1 shows up in the COM port section. You no longer need this configurator, so you can exit out of the Chrome configurator. You're going to go to your folder that has your client in it, which in this case is Windows x64. You're going to open your configurator, and it will automatically detect your flight controller as it's connected. Here we have several options for setting up your flight controller. It's very easy to go through the wizards, and I'll go ahead and walk you through them now. You'll go to set up your flight controller, that is the first option, and you'll place your quad flat. Then press next. Then you're going to put your quad on its nose and press next as well. And your FC orientation has been set up. Now we're going to go ahead and detect your receiver. For this, you're going to want your remote, and you're going to want to turn it on and make sure that it's bound to your receiver and at least 10 feet away. Once you have verified that, press next. It's going to go ahead and scan for your receiver, and it will automatically detect it. It can be on TX1, TX4, or TX3. Doesn't matter, it will automatically detect it and select the proper UART for it. In my case, this is actually wired to TX4 on S-Bus inverted protocol. As you can see, the automatic radio detection has succeeded. Next, you'll run the setup radio wizard. Leave your radio on for this. Now you're going to be moving your sticks in circles from corner to corner for about 15 seconds. When you're done with that, put the throttle at 0 and leave your other stick centered, then press OK. Now you just follow through the steps. Set your throttle to the top, push yaw to the right, push your pitch to the top, and set your roll to the right. Then you're going to put your arming switch into the disarm position, press next, and then put it in the arm position and press next. Step 4 is complete, and now your radio is set up. Now you can go to the Update ESC tab. I like to turn my radio off for this, and you'll need a battery, and you want to make sure that your propellers are off. So go to Update ESC, select the I have removed the props and connected the battery option. I have not connected the battery, so I'm going to do that now. My props are off, so I'll go ahead and press Update ESCs. This will take about 60 seconds on average, but it's going to go through and run and update all your ESCs to the latest that we have. Currently, this only works for BLHeli and BLHeli-S ESCs, but we are working on adding some other ESC protocols in the future. As you can see, the flashing has finished, and all your ESCs are now updated to the latest. It shows that each one was flashed, and then it does a dump, and it shows all your settings as well. You can press Done. Next, we want to calibrate our motor, so you're going to want to remove your battery. Have your props removed from the last step, so you go ahead and select that. Start motor calibration. Now you're going to plug in the battery and wait for the tones to finish. You should distinctly recognize the calibration tones. When that first set of tones finish, you're going to press OK, and the second set of tones will play. Now you can press Done once those have finished. Next, we're going to go fix your motor direction and idle. You can leave your battery plugged in for this. Again, check the option for removed props and connected battery, and then press Start. It's going to set your idle percent to 5. If you notice that all your motors are spinning, you're going to select Yes. If not, you'll press No. Mine were all spinning, so I pressed Yes. When you wait for all the tones to finish, then you can press OK. And here you can change the directions of your motors. So mine are already set correctly, but you would just enable or disable the switch, and then you'll press Start your motors. The ESCs will play their tones again. Once they have finished, you can press OK, tone's finished, and all the motors will spin up. Here you'll check to make sure that the direction of the motors is correct. If so, press yes. Congratulations, you're done. And now you can literally go take it out and fly. RF1 is done. But there are other options that you can select. Like on the configuration tab, you can select your telemetry and your UARTs and receiver protocol. You can also change the mixer so that you can reverse your propeller direction, which is supposed to give you a tighter feel in the curves. And you can also change your LEDs and set them up here. In the PID tuning page, you have all your PIDs, which are pretty standard, and then you also have your rates. I personally like to fly on low expo rates, and you also have your filtering settings. Here you can configure and set up some of the settings for your ESCs, and there's going to be a lot more options that are coming here soon. You also have your logging tab, which allows you to download a log that you can read in Blackbox or a Blackbox reader. You can format the flash, erase the flash, all from this tab. Then you also, of course, have your CLI, and you can enter commands there, and then you can update your firmware directly from this configurator. You can reboot the flight controller into flight controller mode. You can load firmware locally in Flash, or you can reboot the FC into DFU mode. This is all you need to know to get started with RF1 and go out and fly. Hope you have a blast flying RF1. It's an amazing firmware and flies fantastically. If you need any help getting set up, please feel free to visit us on Slack and talk to any one of us on the team. Also, feel free to contact us at support@raceflight.net or on our Facebook page. Thanks for watching this video. If you liked it, please give it a thumbs up. That really helps me out. And if you really liked it, please give me a sub too. I would really appreciate it. Thanks for watching and have a great day.